Hey guys, welcome back to the channel. And as you know, this is the Polynomials chapter of class 9. And in the previous video, as you know, we did the long division method and we found out the quotient and remainder of the given polynomials to us. So as of this video, we will be doing the factorization method, which will be the middle term splitting and the factor theorem. These two are the methods that we will be following for the factorization method. So if you like this video and these types of videos, and if you want me to continue posting all these videos, then please make sure that you subscribe to the channel and like this video and show your support to this video so that I can make many more videos like these. Now let us move on to factorization. So the first method, as you can see, is the middle term splitting over here and the factor theorem. So we will be seeing middle term splitting for the most part, and factor theorem is rather less used because it has a long procedure and it is a waste of time to do factor theorem. But since it is in your syllabus, we will be doing that as well. And for the most part, we will be doing middle term splitting. So what is middle term splitting of factorization? Well, what is factorization first? Well, if you are given with a polynomial of this sort, ax square plus bx plus c, this is the general form of a polynomial or a quadratic equation for the part. Now, using factorization, we can represent this polynomial in terms of products. So it will be of something like this. So x minus a times x minus alpha times x minus beta, something like this. So you ask, why do we need to represent this in this form? There is a specific purpose for this form. Well, when you start to factorize this equation and do some steps so that you arrive to this form, then using this form you can find the zeros of this equation. You can do many more stuff using this form. So this is a rather useful form which we will be using for the later chapters. So it is better to learn factorization now and give some better importance to these steps. So let us try and understand this middle term splitting method using an example. So the first example I will be using is y square minus 5y plus 6 equals 0. So this is my first example and we will be doing middle term splitting. Now what exactly is middle term splitting? Well, I will be splitting this middle term, nothing else. So I will be splitting this minus 5y to my convenience, such that I can do this factorization and finally arrive with two product terms equal to 0. So this should be my final product case. The final answer case. So what you have to do is basically, if you have an equation like this, ax square or y for the matter, so these both are variables, so ax square plus bx plus c is my generalized equation. Now what I have to do is basically multiply the coefficient of x square, which is a over here, and the constant term c. So you have to just multiply these two, which will be ac, right? A times c would be ac. Now over here, what is the case? 1 y square, right? So you are multiplying 1 with 6, so it is 6. Now what you have to do is basically you have to list out all the factors of this AC and you have to choose the suitable factor. Now we will be doing the same over here. So as I said already, we have to multiply the first term and the last term. So 1 times 6 will give us 6. Now you have to split this 6 into its factors. So 1 6s are 6, 2 3s are 6, 3 2s are 6 and 6 1s are 6. Now there are negative terms as well. So you have to choose negative terms. So minus 1 minus 6 is also 6 because minus times minus becomes plus and 1 times 6 is 6. So minus 1 minus 6, minus 2 minus 3 is also a factor, minus 3 minus 2 and similarly minus 6 and minus 1. So these are all the factors pertaining to 6. Now we got all the factors. What are we going to do with these factors? Well, you have to choose a factor such that when you add them, suppose when I am choosing this first 1 and 6, when I add them, I have to get the result as this middle term, which is minus 5 in this case. The generalized form, as I already told, was ax square plus bx plus c equal to 0, right? Now when you list out all the factors of AC, now you have to choose the pair of factors such that the resulting addition of those factors will give me b, which is the middle term over here. Now in this case the middle term is minus 5. So I have to choose a pair of factors such that it gives me minus 5. Well, let me try 1 plus 6, it is 7, 1 plus 6 is 7 and it is not minus 5. So I am ruling out this factor. 2 plus 3 will give me 5 but it is minus 5, so I am ruling out this factor, and all the such positive factors I am ruling out. Let me try minus 1 minus 6, minus 7 which is not minus 5, I am ruling this out. Well, let me try minus 2 minus 3, so minus 2 plus minus 3 will give me minus 5. Well, it is minus 5, so I will take this factor. Well, you can ask, minus 3 minus 2 will also give me minus 5, so I can take this as well. Well, it is absolutely right. I can take these two pairs for my convenience. So I will be splitting minus 5y in terms of these two pairs. How am I going to do that? Now my next step will be splitting this. So y square minus, I will take this one. So I will be taking this first step. You can also do it with this. So y square minus 2y minus 3y plus 6 equal to 0. What am I doing over here? Just add a y or an x according to this equation and simply add it instead of minus y. So instead of minus 5y, you are just putting minus 2y minus 3y. Basically, when you add minus 2 and minus 3y, you get minus 5y back. So you are just splitting the middle term according to your convenience. Now what convenience do you face over here? Well, you are going to take common over here. So group these terms according to their precedence. So group these two and group these two with a positive sign over here, because you are adding everything, right? So there is no harm in adding a positive sign in between. So now take common outside from these brackets. So y square minus 2y, what is the common? Y is the common. So take y outside, you will be remaining with y minus 2, right? Now plus, when you what can you take common over here? You can take 3, when you can take minus 3 common. So take minus 3 outside. When you take minus 3 outside, you will be left with y minus 2 equal to 0. Now when you try and multiply it, you can check it. So y square minus 2y, when you try multiplying y with this, you can get the same. And when you try multiplying minus 3y plus 6, because minus 3 minus 2 is plus 6, right? So minus 3 times minus 2 is plus 6. So again when you multiply, you get the same thing. So now what is the next step? We have taken the common outside, we have this term over here. Now what do we do next? Well, these two are terms, these two are the two terms over here. Now what you do is take common again. So y times y minus 2 plus minus 3 times y minus 2 equal to 0. What is the common over here? Y minus 2 is the common. Y times y minus 2 plus minus 3 times y minus 2 equal to 0. Well, take y minus 2 outside because it is common in both these terms. So y minus 2 times, now when you take common outside from y times y minus 2, you will be left with y. So y times y minus 2, you are taking y minus 2 outside, you will be left with y. And from over here, minus 3 times y minus 2, when you take y minus 2 outside, you will be left with minus 3. So finally, you will be left with this step, which is exactly the final product step which you will be getting, which is something like this. So you have to get two products, something like x minus or y minus equal to 0 in terms of product. So over here it is multiplication sign. So finally, this is our factorized product, and using this you can do many things. You can find the zeros of this polynomial. So that is of a different matter when this is only for factorization. So using this example, I taught you the middle term splitting, which is a factorization method. Let us try another example for middle term splitting. So this is another example for middle term splitting. So let us try it with this. Now the first step was to multiply these two, 6 and 5, which will give us 30. Now take out all the factors for 30, which will be 30 times 1, 15 times 2, and then what are all the other factors? 15 times 2, and then you reduce it down to 10 times 3. Now 5 times 6 is also another factor. Now again reverse it. So 6 times 5, 3 times, so if you write it once, then it will be the reverse of the same. So if you write 5 times 6, then again 6 times 5, 3 times 10, 2 times 15 will also be the same case. Now write it down for the negative terms as well. So those are also the factors, right? So minus 30 times minus 1, minus 15 times minus 2, minus 10 times minus 3, and minus 5 times minus 6. Because these also give 30. So these are all the factors that we know of, and when you try to reverse it, you will get the same results. So now we have to choose a pair of factors such that we will be getting the middle term, which is 17. 17 is our middle term, as you can already see, and as you already know the step. Now you have to choose such factors, a pair of factors such that you get the middle term. So let us try 30 plus 1. 30 plus 1 will give us 31, which is not 17. We will try 15 plus 2. Well, 15 plus 2 is 17. Right, so we can choose this pair. Now we can either choose 15 plus 2 or 2 plus 15, because both are giving us same result, right? 17. So now the second step was to split the middle terms in terms of 15 and 2. So 6x square plus 15x plus 2x plus 5 equal to 0. Now what I did was simply I split 17x in terms of 15x plus 2x. Since I chose this factor pair, I split it into 15x plus 2x, ultimately it gives me 17x, right? Now what I will be doing is I'll take common outside. So over here, what can I take common? Well, 6 and 15 is there, so I can take 3 common outside. And x square and x, I will group these terms first. Now within this term, what can I take common outside? So 6 and 15, within 6 and 15 I can take 3 common outside, and within x square and x I can take x common outside. So as a whole I'll take 3x common outside, and what I'll be left with is 2x plus 5. So 3x in times 2x will give me 6x square, and 3x times 5 will give me 15x. So and finally I'll be left, I can't take anything common outside over here, so I'll take 1 outside. So 1 times 2x plus 5. So remember that when you can't take anything common outside, then you just take 1, so that you get a clear representation of something over here. Should also always have something over here. Now what you do in the next step is consider these two as the whole terms, and you have to take a common outside. So what do you take common? Always remember that there will be one term like this, 2x plus 5, 2x plus 5. So you have to take that term outside. Now 3 times 2x plus 5, 1 times 2x plus 5. In both these two terms have 2x plus 5 common. Take that outside. So 2x plus 5 times, what you will be left with over here is 3x times 2x plus 5, you will be left with 3x, and 1 times 2x plus 5 will be left with 1. Don't forget this 1 because this is going to be a value over here. Don't forget 1 as such because it is also a number. So 3x plus 1 equal to 0. So this is our final step because we have obtained a product term like this. So something in product equals 0. So this is our final step. So that goes on middle-term splitting for two such examples where we tried and factorized these two equations. Now we will be seeing factor theorem. Now I will be using an example for factor theorem. So let me take the same example, y square minus 5y plus 6 equal to 0. Now why I use the same example is so that you can understand the complexity or the lengthiness of this process. So what you do in this method is take this constant term, this is 6. Now you write down all the factors of 6 or all the multiples of 6. So you can write it down as 2 and then 3, 1, 2, 3 and finally 6. So these are all the factors. Now what you do over here is you substitute the values over here. So you substitute 1 over here, 2, 3 and 6 and the negative terms as well. So minus 1, minus 2, minus 3 and minus 6. So plus or minus, I'll write plus or minus over here. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So these include all values such as 1, 2, 3, 6 and minus 1, minus 2, minus 3, minus 6. Now you have to separately substitute all the values over here. So 1, 1 you will be substituting in place of y, again 2, again 3 and check that if you substitute this and get the value as 0, then you can represent it in the following representation. So let me try and do that. So first I will be trying for 1. So let me try and substitute 1 in this case. So 1 square minus 5 times 1 plus 6. Now what will this give me? 1 minus 5 plus 6. So 1 minus 5 is minus 4, minus 4 plus 6 is 2. Well, when substituting 1, I got 2 as the result, but in the RHS we have 0, so it is not fine. We cannot take 1 as our first factor. So 1 is not our factor. Now let us try substituting 2. So in this step we are substituting 2 in place of y. So 2 square minus 5 times 2 plus 6. Now what does this give us? 4 minus 10 plus 6. Now in turn 4 minus 10 will give us minus 6. Minus 6 plus 6 will give us 0. Well, this does give us a 0 and the RHS is also 0. So we can take 2. So plus minus 2, keep we just substituted plus 2. So keep plus 2 aside. So plus 2 is 1 and let us try substituting another term. So let us try substituting plus 3. So when I substituted 2 and got the result as 0, we can say that y minus 2 is the factor of this given equation. That is the factor theorem. Well, when you try and substitute any case, suppose A, B and C are the factors, then when you try and substitute the same in the equation and suppose you get the answer as 0, then you get the result as y minus A or y minus B is a factor of this given equation. That is the case. So that is the case for factor theorem. Now since 2 is satisfying this equation, we can say that y minus 2 is a factor. So let us write it in a side over here. So y minus 2 is one such factor, and let us try substituting 3 over here. So when we try substituting 3 over here, 3 square minus 5 times 3 plus 6. When we try to simplify this, 9, 3 square is 9 minus 15 plus 6. Now 9 minus 5 is minus 6 plus 6, which will give us 0. Now we get the answer as 0 and the RHS is also 0. So now we can say that y minus 3 is also a factor. We only need 2 factors for a quadratic equation. Now what is a quadratic equation? A quadratic equation has a degree as 2. So as I already told you, a quadratic equation only has two solutions, or the two solutions for y. Now when we do factorization, we only need two factors for the quadratic equation. So since we already got two factors, we'll stop with that. We don't substitute any other things, because we know that what else we substitute over here, will not get 0. So for your sake, we'll just try substituting 6 over here. So 6 square minus 5 times 6 plus 6. When we try simplifying this, 36 minus 30 plus 6. When we try simplifying this, 36 minus 30 will give us 6 plus 6 will give us 12. It is not 0. So 6 will also not satisfy this equation. Well, similar to this, when we try substituting any other factor, we won't get 0. So we'll know that only two factors exist for a quadratic equation. Well, when we get those two factors, just write them in a product form. So y minus 2 times y minus 3 equal to 0 is our final equation. Well, we tried and did this in the same method of middle term splitting, and we got the same factorization. We got the same answer as y minus 2 times y minus 3 equal to 0. So with this, you can know that you have understood two different types of factorization methods, which is the factor theorem as well as the middle term splitting theorem. And the middle term splitting method is a bit more efficient, because you can find out the factors using simple middle term splittings. Where using this theorem, you have to individually substitute all the factors instead of y and find out the solution for it, and then you can obtain the factors. Well, this is a bit lengthy, and imagine if you have a larger number over here instead of 6. Imagine if you have a larger number like 256, or something like even like 30 has a larger number of factors, and you have to substitute more factors instead of y. So that is not an ideal case. Now that is why I tell you, try and practice this middle term splitting method, and it is going to be very useful for you in a future case. If you are going to factorize this, then try and memorize the middle term splitting method and practice it more. So that ends this video, where we saw how to factorize polynomials, and we saw different methods of factorization. Also, we saw the importance of factorization, because this final step is going to get involved in finding the zeros and further calculations. So that ends this video, and if you like this video, then please subscribe to the channel and like this video, so that I can make further videos with your support, and share this video to as many people as possible. So see you guys.